So this one, we want to go through each of the questions. The first question will be, please select the correct statements regarding keys. And this one I have said for many times already in the class, but then I will just go through it one more time. So, super key is set of attribute. Okay, it is unique inside set of attributes which is unique inside relations, which means giving set of values for the attributes inside the key A, B, and C, let's say, inside that super key. It's unique for the whole relation, means there is only one tuple. Okay, it means you can find only one tuple inside of that relation. Let's say relation including of A, B, C, D, and E. Okay, so it also means that A, B, C determines, because there is one tuple, and one tuple means all the attributes. It also means that A, B, C determine A, then determine B, determine C, determine D, and determine E. Okay, so that one is super key. Now the next idea is a candidate key. No, a candidate key first have to be a super key. Okay, first it have to be super key. Secondly, it have to be minimal. Now, first it have to be super key means it must, given one set of values for it, you can find only one tuple. Okay, which means that set of attributes determines all the attributes inside that relation. Because giving one set of attributes from here, you can find only one tuple. One tuple means one value for A, one value for B, one value for C, one value for D, and one value for E. That one is the condition for super key. Next is have to be minimal. What does it mean minimal? If you, let's say, drop C, okay, which means that if you drop C out, just let's see, if you drop C out, means that if A and B still can determine everything, it still can determine A, B, C, D, and E. If this is okay, then ABC is not the candidate key because it's not minimal. Okay, but if, let's say, if you drop A out of this, or you drop B out of this, this makes like A, if you drop B out of it, it makes A cannot determine everything. Okay, cannot determine everything. Let's say it makes that A can only determine A, B, not B, A determine A and C, let's say. It means that it doesn't determine everything. So A is not a super key. So if you, let's say, if you drop B, now if you drop A, you have B. Let's say you find out that B does not determine everything either. So this two means that A and B is minimal, because if you drop one of them, it's failed to become the super key. It's failed to become the key. Okay, it's failed to become the key. So if A and B is minimal, then it is a candidate key. Okay, next is a primary key. Primary key is actually, a table may have more than one candidate key. So from set of candidate key, you may have more than one candidate keys. You're going to select one, and for the others you can set them as unique. So this is critical inside this exam and inside this whole exercise. You need to understand about the super key, understand about candidate key, understand about primary key. Then foreign key is actually Foreign key in relation to is actually the repetition sub. Repetition sub. Primary key in R1 to motor R1 and R2 relationship. That's R1 and R2 relationship. That's what it means. Okay, that is what it means. Okay, so with that in mind, we get back to our homework over here. So you can see that superkey is set of attributes called SK, and that is unique in a relation. It is unique means giving one row, you can giving that set of values for the key, you can find only one row. And it is unique means they have to agree only at one value. They don't have to agree at all the values. Okay, let's just give an example. They have to agree only one value, so it's like this. So you already learned a lot about order and order details. So you see that you have the order ID, then product ID, then the quantity over here. Okay, so for order number one, okay, I can buy product number one and I buy two of them. For order number one as well, I can buy product number two and I buy three of them. Okay, so in this table, order ID and product ID is qualified to be unique, because give one order ID, one product ID, you can find only one quantity. You cannot find two. Okay, because if you can find for one order ID, one product ID, if you have three over here, which means you will not store it. You should update this one. So you should never have repetitions of order ID and product ID at the same time. Okay, you should never have it. Okay, so it means that order ID and product ID is unique, which means that order ID and product ID is the key. Okay, is the key. Okay, but then you don't have to disagree on both. It's okay to disagree on both, but disagree on one is also okay. Let's say for this pair and this, it's valid for one order. For order one, I can buy product one. For order one, I can buy product two. It's okay, but you only have to disagree on one of the two. You don't have to disagree on both. Okay, it's okay to disagree on both, but you don't have to. Let's say you may have order number two, they buy product number three. They buy one of them. It's okay to disagree on both, but it's also okay to disagree on this one. Okay, so you don't have to be disagree on both. Okay, so from here we get back to our exercise. They say by definition of unique, you only require to disagree on disagree. So it must be at least one. Only one disagrees. Okay. You don't have to add them to disagree on all. Don't have to. You see this example? Again, they only disagree on this. They don't disagree on this. But it's still valid. You see, in the same order you can have by product one, the same order you can buy also product two. So it's valid there. So for that, you will select this and you don't select this, because you don't have to be disagree on all the attributes. The next one, candidate key is a super key. This is by definition, we already say. Okay. Candidate key is a super key, but it must be minimal. Okay. And minimal means you cannot drop attributes. If you drop, it failed to be the key, because it's failed to determine all the attributes. It's only determine some of the attributes. So for that, candidate key is super key, yes, okay, which is minimal, yes, And minimal means removing one or more attributes from the candidate key makes the resulted set attribute fail to satisfy the super key condition. So this one is true. So I already have examples here again, like A, B, C is a super key, yes, because it determines everything, because it can find only one tuple or one set of values for A, B, C, D. But you can remove C, and A, B still can determine everything. So A, B, C is a super key, but not minimal, because you can reduce it here. But A and B is minimal, because if you reduce B, make A not determine everything, so it's not a key. If you reduce A, make B not determine everything, so it's not the key. So it is minimal. Okay. So that one is true. Next one, primary key is a selected one from the set of candidate keys, and other candidate keys, if there are, can be constrained using unique. This one is true by definition, and it comes straight from the slide. Next one, foreign key is a repetition of the key attribute or unique attribute from the relation in another relation to moderate the relationship. This one is also true. You can look at the straight definition from the slide as well. So a candidate key must satisfy the condition of a super key. Yes, because by definition, a candidate key is a super key first. Okay, it's first have to be a super key. Okay, so and it's at more constraint. And other candidate keys, if there are, no, sorry, candidate key must satisfy the condition. So this one is true. Next one is super key must satisfy the condition of candidate key. No, okay, the candidate key must be a super key first. That's why I satisfy condition of super key. But super key may not need to be minimal. Okay, so that is false. So this one is false. Don't select it. And a primary key must satisfy the condition of a candidate key. This one is true because by definition, primary key is selected one from set of candidate key. So it has to be candidate key. Okay. So there can be more than one primary key. Now, there is only one primary key. Next one. There can be more than one candidate keys for a relation among which one selected to be primary key. This one is true. It is just a different way of writing this. Okay, it's just a different way of writing that, so that should be true. Okay, so the next questions will be, please select set of function dependencies that are true given A1, A2, A3 determine B1, B2, B3. And be careful, this one they say they are true only. As long as they hold, okay, they not need to be equivalent. So for the first one, it is true because it follows the trivial rule. We just add A. And A1, A2, A3 determine A1, of course, because A1 will determine itself. This is trivial. And it's given that A1, A2, A3 determine B1, B2, B3. So B1, B2, B3 here is the correct one. The second one, so this one you should select. The second one is also true. Okay. Because A1, A2, A3 determine A1, A2. This is trivial. Okay. The next one, A1, A2, A3, C1, C2, C3 determine B1, B2, B3. So this one is also true because it follows the augmented rules. C1, C2, C3 determine C1, C2, C3 themselves. And A1, A2, A3 determine B1, B2, B3 is given. So this is also true. Now, A1, A2, A3 determine D1, D2, D3. This one is not true because it's never said anything about that. We never said anything about D. We only given A and B. Next one is, this one is not true because given A determine B doesn't mean that B determine A. Okay, giving one values of A, there is only one values of B, but giving one value of B, it doesn't mean that you can find only one value of A. So this one is not true. This one is not true. So that one is the second exercise. Now, the third exercise over here, we'll see that. Please note that select the set of functional dependencies that are equivalent, which is equivalent. They are the same as saying the whole thing over here. Equivalent, okay? It's not just true, it's not just whole, but equivalent, have to be equivalent. So for this one, it's true, but it's not equivalent. So because you're only telling that A1, A2, A3 determine B1, but actually it can determine more, okay, like B2, B3. So for this one, it is also false because you're missing. It says that A1, A2, A3 can determine, of course, A1 is trivial. This can also determine B1, B2, and B3. But in here, they only say it can determine B1 and B2. So not equivalent because you're missing B3 there. This one, you're telling that this one is true because following the splitting rules. A1, A2, A3 determine all of them. So this one is trivial. So you can always drop. And you tell that A1, A2, A3 determine B1, okay, here, determine B2, here, determine B3, here. So this one is correct because it's equivalent as this. And actually, it is a splitting rule. Okay. From here, this is true. Okay, this is also true, but they are not telling, so they are not telling about determining B, so it's not equivalent. This is true, this is true, this is true, but they are not telling about determining B, so they are not equivalent. So this one is not true, this one is not true. The next one, please select the set of functional dependencies that hold given the same thing here. So that holds only. So from here we see that we can always drop this because it's trivial. So it's become A determine B and B determine C, which means that A1, A2, and A3 will determine C1 and C2. This one is transitive dependencies. And from here, you can split it out into this and into this, so it's true. And this one, this exactly is the same as this, so it's true. Okay, now we are saying that A1, A2, A3 determine C1, but have to be 3 of them. So only 2 of them may not determine C1. So this one is not true. Similarly, this one will not true. Okay. Next one, we say A determines C. It doesn't mean that C won't determine A. So this one is not true. This one not true. This one not true. Similar, C determine A is not true. When we say A determines C, it doesn't mean that C determines A. Okay, so not true, not true, not true. Question number 5. Select correct statements. This is critically important. It is very, very, very important. So let me just go back to the slide and make the definitions again. So why this definition is important? It's from the slide. You can have some exercises over there, but I will show you one exercise here as well. So when we say there is a relation R, which is having A, B, C, D, and E, and we say the definition of the closure of a set of attributes A and B, and it is written as A and B plus. Okay, so this one is closure of a set of attributes A, B. Okay, and given, okay, and it means given set of functional dependencies. function dependency S. Okay, and that set of function dependency S I won't tell later. But then it is written as AB plus, and it means that it is a set of attributes. Again, it is a set of attributes. It's set of attributes as well that A, B can determine. So again, closure can determine given S. Now this is very important, because but it has set up attribute and set up attribute again, then it may be confusing for students, so I have to go through it one more. Again, closures are a set of attributes. Let's say that set of attribute A and B given set of function dependency S, I'll tell later, and it is written as AB plus, and it means that it is a set of attributes, again another set of attributes that A and B can determine. So let me give an example. Given again still R, A, B, C, D, E, and you also know that A determines C, B determines D, and C determines D. Okay? C determines D. Now, let's say C determines D. Yep, that's make it. I want to make it C. I want to make it more complicated a bit. A determine CD, then I want to find some examples which is more meaningful a bit. Mrs. Pooh. Just leave it this one. Let's make it simple. Okay. So now this one is set of attributes function dependency S. Okay. Then I want to find the closure of A and B. Closure. It means that it is A and B plus, and it's gonna be set of attribute that A and B can determine. So you will say that okay, it's first A and can determine A for sure, B can determine B, so AB can determine A, AB can determine B, and A can determine C, you know, from here, so you add the C in. B can determine D, from B can determine D, so B can determine D, so you can add the D in. C can determine D as well, but it's already D is already there, so it's there. Which means that given S, A and B can determine A, B, C, and D. Again, which means that A, B, C, D is the closure of AB, or it is closure. It's closure of AB. Okay, so next from here is AB. The next question is AB the super key for this relation? Okay, it is not, because A and B, for given one A and B, you can find one A. Given A1, AB, B1, one set of AB, you can find only one A, one B, one C, one D, but you may find more than one E, E1, E2. Okay, so why you can find more than one E? Because A and B can determine only A, B, C, D. It cannot determine E. That's why A and B, there may be more than one E. And if there is more than one E, let's say E1, for same A1, B1, C1, D1, I may find E2. Which means that giving A1 and B1, I may find two tuples. or two rows. So which means that A1, B1 is not unique. It's repeated here. Okay, it's repeated here. So it cannot be the key. So in order to make sure that it is a key, it have to, if it is a key, it have to say key determine all attributes. Okay, because key is unique inside the relation. Giving one key, you can find one tuple. One tuple means it's one value for all the attributes. Okay, so this is pretty critical. That's why you can say if A, B, and E, let's say plus, because you still miss one E over here. I just do the augmentation. Okay, I add the E to that. Then right now should be equal to A, B, C, D, and E. Which means that giving A1, B1, E1, I can find only A1, B1, C1, D1 because A and B determine A, B, C, D. You only find one. Then because E1 over here is only E1, E1, which means one row only. So it's unique. Okay, so you have A2, A1, B1, E2. You may find A1 again, B1 again, C1 again, D1 again, but this is E2. So it is actually two rows. Okay, this is actually two rows. But if you consider three of them, if you consider only A and B, there are two rows. But if you consider three of them, okay, A1, B1, E1, you can find only one row. Or A1, B1, E1, you can find only one row. Okay. So again, if it is a key, it has to determine all the attributes. Okay. So in this case, A, B, E, close out of it, it includes A, B, C, D, E, which means all the attributes, which also means A, B, E determine A, determine B, determine C, determine D, and E itself determine E. So A, B, E determine A, B, C, D, E. What it means again is giving one value of A, one value of B, one value of C. You can find only one value of A, one value of B, one value of C, one value of D, one value of E. And one value of A, one value of B, one value of C, one value of D, and one value of E means only one tuple. This is very, very, very important. So again, because it is important, so the following things are equivalent. Okay, A, B, let's say here, A, B, E plus, which means closest of A, B, closer, sorry, not closer, closer of A, B, E, okay, equal A, B, C, D, E, which means that it include all attributes. Okay, it's include all attributes, which also means that A, B, E determines all attributes, which means that A, B, E is a super key. So all these are equivalent. All these are equivalent. So when you say A closer of ABC or ABE plus determine everything, then it's a key. When you say it's determine everything means include all of the attributes of the relation. So ABE determine all the attributes, which means that giving one ABE there is only one tuple, which means that ABE is a super key. So this thing, I'm sorry to keep repeating, but it is important. Okay. So we get back to this one. Select the correct statements from here. Write definitions of BCNF, Boy's code normal form, conditions under which anomalies do not exist, and the left-hand side, okay, of any non-trivial functional dependency is also a super key. So that one is, you say if you see something, okay, if you see something, then the left-hand side determine right-hand side, and this left-hand side must be a super key. And if it's left-hand side must be a super key, it means that it's this one is super key. It means that it must determine all the attributes. Left-hand side must determine. This one is the left-hand side. Left-hand side is the key, which means that the left-hand side determine all the attributes. Okay, which also means that the closure of left-hand side, which is closure of left-hand side, includes all attributes. Okay, closure of the left-hand side includes all attributes because they mean the same thing. So get back to this one. By this is the definition, and the next one is not, because this one they say about right hand side. Okay, then a condition under which anomalies do not exist, but closure of the left hand side. Okay, closure of the left hand side. Okay, includes all attributes. So this one is a correct one. It's equivalent with this, as I already said, because they say left hand side is a super key. It's the same as saying the closure of the left hand side includes all attributes. Again, as I said from here, left hand side is super key. It's the same that the closure of the left hand side here, closure of left hand side includes all attributes. Okay, then next one, let me go through. Then the next one is the condition under which don't exist, and right hand side, no, not right hand side. So this one is not, because it's a different way of, this is original definition, this one is different way of explaining that original definition, and this one is also true. Again, it's just different way of writing the same original definition. This original definition comes straight from the slide, but this one is true because it said that the left hand side can determine all attributes, which is this one. The left hand side determine all attributes. Okay, so those are the three different ways of writing the same thing, and this one coming from original definition, this one comes from the definitions of the super key. Okay, and this one comes from the definitions of the this one definition of the key, this one definition of the closure, sorry, not closer. Okay, so the video is pretty long already. I will pause it and create another one to the next one to continue.